Reaching Mars is one of the humanity's biggest dreams, but there is a serious problem. With today's rockets, a trip to Mars would take around 7 months. That means astronauts would spend more than 200 days in deep space exposed to a dangerous cosmic radiations. And the longer they stay in space leads to the more dangers to their mission. So scientists started asking a bold question. What if we could build a rocket that travels twice as efficiently as the rockets we use today? A rocket is powerful enough to cut the travel time to the Mars almost a half. The answer might come from a surprising source. It is nuclear powered rockets. The limits of today's rockets. The rockets we use today depend on chemical fuel. They burn fuel and oxygen together, creating an explosion that pushes the rocket forward. This technology has taken us to the moon and far beyond, but it also has limits. Most chemical rockets today have an engine efficiency level of about 450. This number simply shows how effectively a rocket uses its fuel to create thrust. A higher number indicates an more efficient engine providing greater thrust while consuming less fuel. Now this is where nuclear rockets become very interesting. How nuclear rockets works. Instead of burning fuel in a normal rocket, a nuclear thermal rocket uses a small nuclear reactor. Inside the engine, nuclear fuel produces enormous heat. That heat is used to warm hydrogen fuel to extremely high temperatures. The superheated hydrogen blasts the engine at very high speed, producing a powerful push, and the difference is huge. While chemical rockets have an efficiency level of around 450, nuclear thermal rockets can reach almost 900. This makes them twice as efficient as traditional chemical rockets. This increased efficiency enables spacecraft to carry heavier payloads over longer distances with smaller fuel supply. And most importantly, it could reduce the time needed to reach the Mars planet. The future of nuclear space travel. Nuclear thermal rockets are only part of the story. Scientists are already working on another powerful idea that could change how spacecraft travel through deep space. But nuclear propulsion does not stop there. Scientists are also developing nuclear electric propulsion systems. The reactor creates electricity to run the engine instead of just burning the fuel. That electricity uses electric thrusters to slowly push charged particles out of the spacecraft. These engines produces much less thrust, so they accelerate slowly, but they can keep pushing for a very long time, slowly building up high speeds. Some advanced designs could reach efficiency levels of around 5000 or even higher. That 5000 rating is over 10 times better than the rockets we use today, like those from SpaceX. It is the difference between a race car that runs out of gas in minutes and a super efficient plane that can fly for days in a single tank. Because of this, many engineers believe the future of deep space travel may use both types of engines together. It includes a nuclear thermal rocket that provides the powerful push to the rocket to leave the Earth, while nuclear electric engines could handle the long journey through space. Conclusion. For decades, scientists have studied nuclear propulsion. Experiments began as early as the 1960s and the results were incredibly promising. Even though scientists have tested them on the ground, a nuclear rocket has never actually launched into the space. But that may soon change. As space agencies and the private companies plan missions to the moon and Mars, nuclear propulsion is once again becoming a serious option. The rocket that finally takes us to the other planets might not run on fire and fuel. It could be powered by atomic energy. Mention your thoughts about this video in the comment section below. Like this video, share it with fellow space enthusiasts, and subscribe to Galaxora for more amazing discoveries and future space missions.